Hi everybody, we're up to our next type of factoring. So let me remind you, so far we have done factoring the difference of two perfect squares. We have done the greatest common factor. Yesterday we talked about factor by grouping, and today is going to be factoring trinomials. So when you look at the do now, and this is a basic, you guys can do either double distribute, which I know a lot of you like, or another method would to be set up the box. X plus 7 times x plus 3. So now either way you do this, you get x squared, you get 3x, you get 7x, and you get 21. When you simplify your like terms, you wind up with an answer of x squared plus 10x plus 21. Okay? So your example from your do now, x squared plus 10x plus 21, is what we call a trinomial. So kind of makes sense, tricycle, 3 terms. And you see 3 terms here. You see an x squared, a 10x, followed by a 21. So we're going to go back to that, and we are going to find the factors that we would multiply to get that. And if you look back to the original of the do now, x plus 7 and x plus 3. So I want you to tell me how x plus 7 and x plus 3 relate back to x squared plus 10x plus 21. Well, notice, if you take a second, 7 plus 3, add to 10, and 7 times 3, multiply to 21. So your two numbers that are in your parentheses, the 7 and the 3, okay, here they are, 7 and the 3, they add to your middle term, and they multiply to your last term, okay? That's what we're going to be doing today. We're going to take what we did in the do now and just go in the reverse. So when you look down here and it says we're going to look for the parentheses that when multiplied together give us x squared plus 7x plus 10. So here's your starting point. We start with 2 empty sets of parentheses. Similar to the difference of 2 perfect squares when we open up 2 sets of parentheses, that's not the same of difference of 2 squares. Remember when we do GCF, we pull out a greatest common factor and open 1 set of parentheses. But trinomials is similar to difference of 2 squares where we immediately open up 2 sets of parentheses. Okay, now we ask ourselves, what would go in the beginning of each set of parentheses? Well, we ask what multiplies to x squared. And most of you will know that x times x gives us x squared. And that's why in the front of each parenthesis, we put an x. Now, the harder part are the numbers. We're going to figure out what 2 numbers are going to, notice, add to 7, that's your middle term, and multiply to 10. So think about what 2 numbers are going to, same 2 numbers. What adds to 7, and what same 2 numbers multiply to 10. Most of you have probably gotten it by now. 2 and 5. 2 plus 5 is 7, and 2 times 5 is 10. And that's why we put a positive 2 and a positive 5 in each set of parentheses. And that's your answer. This is your answer, x plus 2 times x plus 5. Now, I could prove it to you. We could do what we did in the do now if we wanted to. We could either double distribute or set up a box. But when you do that, you would get x squared, you would get 5x, you would get 2x, and you would get 10. And just like the do now, you combine your middle terms, and you would get back x squared plus 7x plus 10. So you know you're correct by your 2 factors being x plus 2 and x plus 5. Okay, so remember, your middle number, it has to add to your middle term and multiply to your last term. Okay, so maybe make a little note of that. Okay, your 2 numbers must add to middle term and it has to multiply. Your two numbers are going to multiply to the last term. Some people like to say AM. Okay, so you could see, oh, A in the middle, M at the end. It's going to add to your middle and multiply to your last term. So now we practice. This is all really just thinking and saying to yourself, okay, here's the number that we really have to think of, -8. You almost want to pull it off to the side and ask yourself, okay, can I name two numbers that multiply to -8? Just pick any two numbers. I don't know. Let's think -8 and 1. Will those two numbers ever add to 2? No. So let's pick other numbers. Maybe -4 and 2. Okay. When I add those together, we actually get -2. So what if I switched up the signs? Because remember, if it's negative, your signs have to be different. So what if I made it a +4 and a -2? Well, guess what? That works. Those two numbers, +4 and -2, they multiply to -8, and they add to +2. So remember, your x goes in the front, just like normal. I need a +4, and the sign goes with it, -2, and that would be your answer. Okay, everybody sees that? Let's try number 2. Okay, we're immediately going to open up our two sets of parentheses. I could take off -6 to the side because I need the factors or the numbers that multiply to 6. I could write them, 1 and 6. I could write 2 and 3. And let's think about this. Multiplied together, 1 and 6 and 2 and 3 will multiply to 6. Will either of them add to -5? No. 2 and 3 add to 5, but not -5. So what other two numbers multiply to 6 and add to -5? -2 and -3. Those are your matches. Those two numbers multiply to 6 and add to -5. So again, put your x's in the front. Here you need a -2 and a -3. And notice this, when your sign at the end, right, here, when it was negative, notice my signs are different. But when my sign at the end is positive, my signs are the same. And that's going to tell you what that sign is going to be. Okay, so let's go to the next one. Let's actually go down to let's go to number 3. So in number 3, we are going to once again open up our two sets of parentheses, and we're going to pull off +12. Okay, and we're going to ask ourselves, okay, what multiplies to 12 and adds to -8? Okay, so let's see, 1 and 12, that won't add to -8. 2 and 6, now what does that add to? +8. So what two numbers will multiply to 12 and add to -8? -2 and -6. So that's an x minus 2 and an x minus 6, and that is your answer. Again, you could distribute to check yourself. Okay, let's try another one. If I do my two sets of parentheses and I pull off my number -35, and I don't know, the first two numbers I think of that multiply to -35 would be 5 and -7, or -5, +7. Remember, your signs have to be different. This sign in the back is negative. It means you have opposite signs when you're multiplying your two numbers together. Now, which pair would get us to add to -2? Which number has to be negative? These two. You want a positive with the 5 and a negative with the 7. So it's a little bit of a puzzle. You're really just practicing and figuring out of that number at the end, your last number, what multiplies to your last number and adds to your middle. So I think I'm going to skip around. I'm going to pass 5, 6. I do like number 7, and I'll show you why. This talks about the order. So in this equation, if you're given x squared minus x minus 56, and it equals this, x plus a and x plus b. They want to know what are the possible values of b. Okay, So can we factor x squared minus x minus 56? This is a basic trinomial. We're going to open up our two sets of parentheses, right? Because that's literally what it looks like, x plus a and x minus b. X plus b, I'm sorry. And you want to ask yourself, okay, what multiplies to negative 56? Now, what does it have to add to? There's no number in front of that x, but what number is that? It's a negative 5. I'm sorry, a negative 5, a negative 1. So let me tell you this, when you have a number in front of your x value, when there's no number in front of your x value and it's a 1, it means your two numbers should be consecutive because they'll have a difference of 1. So what two consecutive numbers multiply to 56? And that would be 7 and 8, negative 7 and 8, or 7 and negative 8. Which pair would add to negative 1? You need your bigger number to be negative, so I would need an x plus 7 and an x minus 8. This was a Regents question, and a lot of kids got it wrong because they were like, oh, the value of b could be negative 8, which I agree. But what else could b also be? It really could also be 7, because wouldn't a student be correct if they wrote x minus 8 first and x plus 7 second? The order never matters. The signs matter, so it matters if you put a negative 7 instead of a positive 7. The signs matter, but it doesn't matter the order that you write your two factors. So here, b could be negative 8 or positive 7. Okay, I'm going to just show you one other thing. If you look down here, they also could ask you the same type of basic trinomial. The only difference is your first term, instead of being x squared, is x to the 4th, and your middle term is x squared instead of just an x. There's really no difference. You factor this just like you would factor a basic trinomial. The only difference is, instead of putting an x in the front of each parenthesis, you're just going to put an x squared in the front of each parenthesis. You're still going to pull out your 7, and you're going to ask yourself, okay, name two numbers that multiply to 7 and adds to 8. Well, there's only like one pair of numbers that multiply to 7, 1 and 7, and those add to 8, plus 1, plus 7. Done. Notice there's nothing next to my 1 and my 7. So most kids will want to put x's next to there. Do not. Because again, when you distribute, if you do box method or double distribute and you multiply this to this, this to this, this to this, watch what I get. X times x squared is x to the 4th. X squared times 7 is 7x squared. 1 times x squared is x squared. And 1 times 7 is 7. And once again, I have two like terms in the middle. And look what I get back. 7x squared plus a 1x squared is 8x squared. So that is exactly what I started with. And there you go. The only difference is, okay, use x squared in the front of each parenthesis. Okay, so let me try number 9. Again, open up two sets of parentheses. You have a basic trinomial. Your first term is x to the 4th, so instead of an x and an x, it's going to be an x squared and an x squared. And can you name the two numbers that multiply to 64 that add to 16? It's an easy one, right? 8 and 8. Plus 8, plus 8. 8 times 8 is 64. 8 plus 8 is 16. Okay. Look at your next one. A little bit of a bigger number. Okay, you have that x to the 4th, so I'm putting x squared and x squared. You have a positive 99 out front. Name some numbers that multiply to 99. I mean, you could say, 1 and 99. You could say 3 and 33. Do either of those add to 20? No. How about 9 and 11? Yup, there it is. Plus a 9, plus an 11. is someone correct if they write x squared plus 11 and x squared plus 9? Yeah, either one is the same thing. That is correct. Okay, one more and I'll let you guys go on your own. I'm going to once again open my 2 sets of parentheses. X squared's coming down in front. I'm pulling off 40, and I'm asking myself, what 2 numbers multiply to 40 that add to negative 13? So I'm immediately thinking, okay, 4 and 10, but they would add to 14. What else for 40? 2 and 20? Nope, they're not going to add to 13. How about 5 and 8? Well, those two add to 13, except they don't add to negative 13. So what if I made them both negative? Because a negative times a negative will give you the positive, and a negative plus a negative will give you that negative 13. There it is, x squared minus 5 and minus 8. Your puzzle was what 2 numbers multiply to 40 and add to negative 13? That's negative 5 and negative 8. Okay, that's it, guys, for today. Why don't you guys let me know how this one goes? I will fill out these last 2 for you. Here, I'll do them right now. These have just an x squared in the front, so if I pull down my x's, what multiplies to negative 24 and adds to negative 10? Ooh, this is a good one. Everybody's going to say negative 4 and negative 6. Negative 4 and negative 6 would multiply to positive 24. It's got to be negative 12 and positive 2. So that, again, the order doesn't matter, but the sign matters. It has to be a positive 2 and a negative 12. And here, this last one, what 2 numbers multiply to 64 and add to negative 16? 2 negative 8s, negative 8, negative 8. So if you are struggling with this, why don't you guys contact me as soon as possible and we could set up a Google Meet for a little extra help tomorrow. You let me know, either tomorrow or the next day. Okay, bye guys.